So in the last lesson, we learnt about planes and anchors and implemented this delegate method to be able to detect horizontal planes in the real world. Now in this lesson, I want to look at how we can start detecting touches on the screen and interpret it as locations in the real world. So to do that, I'm going to use a delegate method called touches began. And this gets called when a touch is detected in the view or in the window. So in here is where we're going to be receiving those touches that are coming from the user and use ARKit to convert it into a real world location. So the first thing we need to do is to check if there indeed were touches detected, and this method wasn't just called in error. So to do that, we're going to use a iflet, and we're going to call our object touch, and it's going to be set to equal touches.first. Now, if you option click on touches began, you can see that touches is actually a set of UITouch instances, but they only have more than one object when you're using multi-touch. And to do that, you need to enable multi-touch. But in our case, because that's not enabled and we're not interested in detecting multiple touches, we only want the first object in that set, which is the location that the user touched on the screen. So if this touches.first does indeed contain an object, then we're going to assign it to touch and we're going to be using it in order to detect its location. So let's create another constant called touch location and set it to the touch that the UI touch that we got from earlier on, dot location. And the in is where that location was detected. And you can see that the location is expecting a node that is a descendant of a scene presented in the window that received the touch event. So this is going to be our scene view, because that is where our touch event was initiated. All right, so once we've got the touch location, remember that this is a 2D coordinate because your iPhone or your iPad screen is 2D. You can't actually push through the iPad and touch a place in 3D. So in order to convert that touch location into a 3D location inside our scene, we're going to use a method that is from ARKit called hitTest. And I'm going to show you how it works. So we're going to call the results, and it's going to be created by calling one of the scene view methods called hitTest. And hitTest searches for real world objects or AR anchors, which is true in our case because we're looking for plane anchors, that is in the captured camera image corresponding to a point in the scKit view. So basically we're converting a point that we're touching in 2D space on the screen into a 3D coordinate that corresponds to one of our AR plane anchors. And the hitTest method that we want is this one, where it expects a point that's going to be our touch location, and it's also expecting a type, which is the type of result we're looking for. So the point that we're going to run our hitTest on is going to be touch location, and the type is going to be dot existing planes using extent. And this is a plane anchor that's already in the scene because we put it on in this delegate method, and it's respecting the plane's limited size. And now I just want to briefly explain how this hitTest works. So let's say that you've got your app running and you tap a point on your screen. Now that tap is interpreted as a touch location, and that will trigger the touches began method, and we're going to look for the location of that touch. Now that touch location is a point in 2D space. It has a X and a Y component on the iPhone or on the iPad screen. Now what we want though is we want to convert that 2D location, and we want to let it traverse through the camera image and hit a point in 3D space. So a place on our plane that we've already added to the scene. So now that point that the hitTest has detected within the scene has a third positional component, the Z component. So it is now a position in 3D space. And this is the point that we're going to be placing our dice. So depending on the Z component, your dice is going to be rendered larger or smaller. So if the Z was closer to you, then your dice would get rendered larger, and if the Z was further away, then it would be scaled down smaller. So it's being placed in our 3D plane based on our real horizontal plane that was detected. Now, if you're interested in finding out more about how AR hit test works, then have a look in the class documentation on apple.com, and you can read more about what are the different types of hit tests and what are the parameters for this particular method that we're using and how it works behind the scenes. Now, once we've gotten our result back, I want to be able to print to the console and say, if the result is empty, i.e. we didn't get one, then that means that our hit or our touch probably didn't hit one of our existing planes. So I'm going to say you touched somewhere else, but if it was not empty, i.e. we did get a result back, then I'm going to print that you touched a point on the plane. So let's say if results dot is empty, and we're using is empty because results is an array type. So I'm going to put the exclamation mark in front of results.isEmpty to reverse it. So we're now checking to see if results is not empty. And in that case, that means we did get a result back from our hit test, and it did find a position on an existing plane. So we're going to print touched the plane. But otherwise, our touches began was triggered, so the user did touch somewhere on the screen, just not on an existing plane. Then we're going to print touched somewhere else. All right, let's try that. So as you can see, when I touch the plane that is level with the desk, it says touch the plane. And if I touch somewhere else, like say this slightly more elevated box that's wrapped in a pink shirt, touch somewhere else. And it works even if I move the camera somewhere else and the original plane is out of the view.